Hey everyone, my name is Jeremy McPeak for NetTuts, and welcome to another lesson of ASP.NET from scratch. In the previous lesson, we started with the MVC framework, and we replicated the email form application that we wrote in the first two lessons of the series. But we didn't go into detail about the framework. We just kind of brushed over the models, the views and the controllers, and model binding and things like that. So we are going to spend some time looking at each component individually and in detail. And first, we're going to start with the URL routing engine. Now, in the previous lesson's comments, somebody made the comment that routing really wasn't that special, that it was available in the .NET framework and you can use it in any web application. That's true. The system.web.routing namespace was added to the .NET framework in version 3.5, but the MVC framework was really the first framework to have it built in. If you wanted to use it in your own application, you had to do that yourself. That did change with version 4. Web Forms does have its routing engine built in, so you can use that in Web Forms, and of course MVC continues to use it. But it's a pretty powerful feature, and it's often confused with URL rewriting. URL rewriting is the process of rewriting ugly URLs into pretty ones. That's basically all it is. The user uses the pretty URL to make a request to the server. The server's rewriting engine translates that into the original URL based on a set of rules, and then it serves whatever file that URL is pointing to. It's all transparent to the user. There's really nothing that you need to know about it except that URL rewriting typically serves actual files on the web server. Routing in the MVC framework, however, doesn't serve actual files. Instead, you serve the result of calling an action method on a controller. When an MVC application receives a request, the routing engine looks at the URL and compares it to routes in a route table. If it finds a match, then it routes that request to the appropriate controller and action method. But if a match can't be found, then control is passed back to the web server, and then the server attempts to serve an actual physical file. Now we can kind of see this if we look at the application from our previous lesson. And once this loads up, I'll press F5 to run this. Our little development server starts up, and we get an error. I do have IE9 beta installed, and I do get this problem every time I debug an application. Obviously, it is a bug with Internet Explorer 9. Beta is beta. Hopefully it will be fixed, but right now it can be gotten around by just refreshing the page. So there we go. Let's click on Contact Me. Let's look at the URL up here. Now we know since we wrote this, we don't have a home folder and we don't have a contact subfolder there. So we know that this location actually doesn't exist on the file system. But what happens here is we make a request with this URL. The URL is compared with the routes that we have within our route table, and then the request is routed to the home controller and the contact action method on our home controller. So let's look at our home controller class. And we'll see that we have two contact action methods. We have one for get requests, which is what we just saw, and then we have one for post requests. So let's take a look at our route table to see how this works. The table is located in the global.asax file. This is a file that is general to ASP.NET. It is not specific to MVC, and it's used to house the application and session level event handlers. So we can handle just about every application level event that we want to. The only event being handled is the application's start event. So when that event fires, this event handler executes. And we have a method here called register routes, which is a static method that we use to add routes to our route table. The first thing to note in this register routes method is this call to ignore route. What this statement does is this tells the routing engine to ignore all requests with an AXD extension. The MVC team added this method because they realized AXD files didn't actually exist on the file system, so they needed some way to tell the routing engine to ignore those requests. So anytime you want to ignore certain requests that match a particular pattern, you can use this ignore route method. The second statement calls the map route method, and this adds a route to our route table. Right now it's accepting 3 arguments. The first argument is a string value that contains the name for this particular route. In this case, it's default. The second argument is another string value that contains a pattern to match URLs with. So if an incoming request is handled by the routing engine, it will take that URL and try to match it with this pattern here. If it matches this pattern, then it will use this route and it will route to the controller and the action method. The third argument is an object that contains default data for our route. So if a request comes in that doesn't specify a controller, an action, or an ID, then these values are going to be used. And let's take a look at this pattern here. We have a pattern of 3 segments. By segments, I mean these pieces of data that are divided by the slashes. So we have a segment for the controller parameter, we have a segment for the action parameter, and we have a segment for the ID parameter. So this pattern is going to match any URL with 3 segments in it. So if somebody was going to make a request called foo bar and then 123 and request our application with this URL here, the routing engine is going to match this URL with this particular route. It's going to use foo in place of controller, bar in place of action, and 123 in place of ID. And what it will actually do is it will look for a foo controller class. It will create an object of that class, and then it will call the bar action method on it, and it will pass the data here, 123, to that action method. So we can actually test this and see this in action. Let's add a foo controller class, and we need a public method. It's just going to return a string, and it needs to be called bar. It also needs to accept some data. We're just going to do string ID, and let's just return hello world space, and then we'll concatenate the data that's passed to it. So let's press F5 and run this, and we haven't modified anything in our routing table, so this should work. And it's going to pull up our home controller first, the index action method. But let's request foo bar and then 123. And here we have hello world and then 123. So this route is working for us, and really anything that we put in this third segment is going to be displayed on the screen here. So we could just type whatever we want and it's going to end up here. And we can get specific with ID here. Instead of accepting a string, we can actually specify some other data type. I'm going to change it to int to represent a number. We'll add toString here, and we'll run it again. And we'll request foo bar 123. And we are getting, as we expected, hello world, then 123, and that's because 123 is a valid number. But if we put some type of string here, then we are going to get an error because this string cannot be converted to an integer. Now we can actually handle this a little bit better by using constraints within our route, and we'll look at that in a few minutes. But for the time being, I'm going to change this back to string because string is a lot more lenient. We don't have to worry about what type of data is being passed as this ID parameter. Well, let's play around with these default values that we have here. First, I'm going to run this again so that we can look at this URL here. We are getting, or we are requesting the root of our application, but we are still matching the index action method on the home controller. Well, why is that? That is because we are specifying default values for each of these parameters here. And since the segments are omitted, the default values are being used in place. So we can actually change the controller and the action to other controllers or action methods, and those would come up by default. We could also remove this optional component here to ID, run it, and then we can see what happens. We'll actually get a 404. And that is because ID is no longer optional, so we have to explicitly specify the ID parameter. But in order to do that, we have to specify the controller and the action as well. So here we are getting a 404. Our simple URL is not sufficient enough anymore. So if we specify home, let's look at contact. Even if we use this isn't going to work. So we just have to specify something for the ID, and then the contact action method will be called. So whether or not you specify default values or optional parameters does determine how a URL is matched with a particular route. So do be careful how you do that, because you can affect how your application will work for particular URLs. Now there are times when we want a little bit more control over how a URL gets mapped to a controller. And as an example, let's look at this URL here. It's going to have a year, a month, and a day. 2010 for the year, 09 for the month, and 22 for the day. This is common, especially within blogging software. So if our application gets a request with this URL, it's going to match this pattern here. And that's a problem, because we don't have a 2010 controller, and it's really not feasible to have one, because then we would have to have a controller for every year, and we would have to have an action method for every month. There's got to be a better way to do this, and there is. We can't just simply copy this route, because then the application would get confused. These patterns are matched according to segments, and if two URLs are coming in with 3 segments, then it really doesn't know which route to use. Even if we change the data that's being passed here, for example, if I change this to blog, controller to year, action to month, ID to day, if we change these defaults to blog, post, and then day here, we're still going to have an issue, because both of these patterns have 3 segments. So this is where constraints come in. Constraints allow us to restrict what controller a request is routed to. To use constraints, we pass another object to the map route method. This will be the 4th argument. It is going to be another anonymous object, and its properties are going to be the same as the parameters within our URL pattern. The first restriction we are going to place is going to be on the year parameter. Years are typically represented by 4 numeric characters, so we'll use a regular expression to specify that. So here we have a regular expression saying that 4 numbers. We'll do the same thing for month, except that we will specify 2 numeric characters. 2. Oops. And then we'll do the same thing for day. And notice I am using the verbatim operator here. If we took that out, then we would have to escape the slash here. It's a personal preference. I don't like to escape anything if I don't have to, so I'm using the verbatim operator. Let's also get rid of this optional parameter here, because we want to specify year, month, and day. Now we need to add a blog controller class, so let's add a blog controller class, and we need to create a post method. It's going to return a string, and since we are getting 3 pieces of data, year, month, and day, this post method needs to accept int year, int month, int day. And let's return a date string, so return new date time. We'll specify year, month, day, and then we'll call the too-long date string. So if I press F5 and run this, we'll test 2 scenarios. We'll test to make sure that our home controller still works. We can also check on the foo as well, but we'll also make sure that the route with the constraints for our date work as well. So first, let's just check our default route here, and we are getting the home controller, the index action, and we are also getting our contact page here. If we go to foo and then bar, and we are getting that controller as well. So now let's check the route with the constraint. And I have a URL here for today's date, and we can see that that is working fine too. Well, let's make our date request here hackable. And by that, I mean let's make it so that we can request just a year and a month, which is also common in blogging software, so that we can see all of the blog posts for a particular year and month. The first thing we need to do is we need to copy our blog route, and we need to give it a new name, blog-year-month. And the reason for that is because no two routes can have the same name. Next, we'll get rid of the day parameter, and we'll get rid of the day constraint. And we also need to change the action method here. And I'll show you why. If we have two overloads for an action method, which I am writing right now, year and month, whenever a request is received, and it could be either 2010-09-22, 10-09, our routing engine knows that these URLs need to go to our blog controller due to these constraints that we have here. And it also knows that it needs to go to the post action method, but it doesn't know which action method to call. It would be nice if it looked at the parameters here and looked at the constraints and then decided, oh, I need to call the overload with two parameters. And if it matched this one, that it would say, oh, I needed to call the one with three parameters. But it's not that smart, unfortunately. So we have to give this another name. So we'll just do post year month, and we'll copy that over here. So now if we were to run this in our little web development server, we can see that we get a date string here for today's date. And if we take off the day, we're going to see year and month. And just to show that our other routes are still intact, our home controller and the index action are working, the contact action is working, and of course the foo controller and the bar action would work as well. The last thing we'll talk about is route precedence. How we add routes to our route table is very important, because if they're done so incorrectly, the routing engine could match a request with an incorrect controller. As a general rule of thumb, we want our routes from specific to general. And right now, they're not in that order. We have something specific at the top, and then we have year month, which is kind of specific, but not as specific as year month day. So we need to move this route before year month. So now we have specific, specific, a little less specific, and then the default, which is absolutely generic. And if we can look inside of the route table after everything's populated, we can see why this is important. So let's hit the breakpoint. There we go. Inside of routes, we have 4 elements here. At the first index, we have the ignore route, which is ignoring the AXD requests. That's good. The second element has a URL of year, month, day. That is this route here. That it's also good. And I can tell you that the third and fourth elements are going to be the year, month, and then the default. So everything is good as it is right now. And we can change this up so that we can see why this would be bad if we put our generic at the top. And we need to hit the breakpoint again. Okay, here we go. Once again, at the top, we have ignore route. That is still good. The second element, however, is our generic route here, controller action ID. So whenever the routing engine gets a request, it's going to look at the first element within our route table, which is going to be ignore route. And it's not going to find a match there, so it's going to go to the second element within the collection. And as long as the request is for our home controller or the foo controller, this is going to be great. But if it's a date, 2010, 09 to or 22, this URL is going to match this route here. And it's going to try to create an instance of a controller called 2010 controller, which isn't going to exist. And just to prove that, we'll move that breakpoint. We'll run this again. And we'll see that the home controller, the index action will work fine. Contact action will work fine. If it'll pull up, there we go. The foo controller will work fine, but we'll get a 404 on a date. So be very mindful of how you input your routes into your route table. You always want to go from very specific to very general. And that'll put the plug in the jug. Thanks for watching. I hope you found it useful. I will see you next time.